Today, on how it's made. Cufflinks. Blueberry turnovers. Dashboards. And earthenware pottery. Cufflinks are a fashion trend with definite staying power. They've been holding shirt cuffs together since the 17th century. Early versions were buttons linked by short chains, an improvement over the ribbons and pins the gentlemen of the day had been using to fasten their sleeves. Clothes may make the man, but a set of cufflinks can make the outfit. They add a bit of flash to conservative business garb and convey a sense of occasion. Buttons may be easier, but cufflinks are about taking the trouble to look really spiffy. A pair of high-end cufflinks starts with sterling silver, gold, or platinum. A craftsman cuts out blanks. These blanks will be used for the fronts of the cufflinks. He places one of the silver blanks on a die engraved with a recessed grid pattern. A hydraulic press closes and squeezes the silver blank into the die, transferring the pattern onto the silver. This company has over 1,000 cufflink patterns, some of which date back to the mid-19th century. With these dies, they continue to handcraft cufflinks the traditional way. Pressing the pattern onto the silver has caused the metal to expand, so he trims the excess from the perimeter. There's another benefit to this. The trimming works the silver to harden it. From a plain silver blank to a cufflink face with artistic expression. A craftsperson now attaches a silver stem to the back of a cufflink face. He melts silver solder between the two, and as it cools, it creates a solid bond. The stem's shape is a slightly curved design to allow the cufflink to sit perfectly on a cuff. The soldering torch oxidizes and darkens the silver slightly, so he dips the parts in a sulfuric acid bath. The acid pulls out the black, and the parts become silvery white once again. Next, the brass bristles of a revolving wheel make tiny scratches on the silver to brighten it substantially. Each cufflink now undergoes a very intensive enameling, using a mix of finely ground colored glass and water. Here, the enamelist applies blue glass to the cufflink's stamped grid detailing, and then paints yellow around the perimeter. It takes a steady hand and experience to do an even job. If one color bleeds into the next, it can't be fixed, and she'll have to scrap this cufflink and start anew. Then it's into a kiln, fired to 1,000 degrees Celsius. The heat melts the glass, and it flows into the detailing to give it definition. At the same time, the glass fuses to the metal surface. And then it's back to the artist for another layer of glass. The enameler will repeat this process between 3 and 7 times to produce a perfect luster and depth of color. The color deepens with each layer, and the result is a rich, translucent enamel surface. Leaving the kiln, the enamel is a bit wavy, so the worker files it down until the surface is completely flat and level. Then the cufflinks go back into the kiln for one last firing. He polishes the enameled surface against an abrasive wheel, using a mix of volcanic ash and water for a polishing paste. This takes hours, but it gives the glass enamel a glossy finish. Now the focus returns to the cufflink's stem and the domed spring link fittings that are the closing mechanisms. He heats a needle-thin wire to make it slightly pliable and then pushes it into the fitting to engage a spring that attaches to the cufflink stem. With the fitting installed, he clips the excess wire at both ends. To secure the installation, he hammers the ends of the wire to flare them out, turning them into a kind of rivet. With the fitting now solidly attached to the cufflink stem, he lightly files the edges with an emery board to give the part a perfectly smooth finish. He buffs the cufflink's exposed silver against a cloth wheel and uses a polishing agent to make it really gleam. After at least 6 hours of work, these enameled silver cufflinks are now complete. In the business world, where men usually dress in a suit and tie, a custom set of cufflinks is one way to express individuality but still fit in with the rest of the guys. A fruit turnover is probably your best bet if you're eating on the go. It satisfies a sweet tooth, it's portable, and it requires no utensils. The dough, typically flaky, is folded over, usually into a triangle or rectangle, and the edges are sealed, trapping the fruit filling neatly inside. These all-natural blueberry turnovers may look and taste like homemade, but believe it or not, they come frozen in a box. You just bake them and eat them. The manufacturer is willing to reveal the ingredients, but the critical proportions, mixing and heating times are top secret. Workers begin making the filling by heating blueberries. Next, they combine lemon juice and starch in a container, then add this mixture to the blueberries. The starch is white now, but will become transparent as it cooks. They mix some more, then add salt. When the starch is opaque, they add sugar and mix some more. As soon as the temperature of the ingredients reaches 77 degrees Celsius, the filling is done. To make the dough, workers first pour flour into the mixer, then salt. After a few minutes of mixing, they add butter, lots of butter. Once it's well blended, they add some water. After a bit more mixing, the dough is ready. This type of dough is called pâte brisée, the French term for a butter-based pastry that's extremely light and flaky due to its high ratio of fat to flour. Workers weigh out 5.4 kilogram portions and put them one at a time into a dough press, with a sprinkling of flour to prevent sticking. The press compresses the dough into a 25 by 40 centimeter block that's 2.5 centimeters thick. They line up the blocks on a floured conveyor belt, joining them together to form one continuous sheet of dough. The dough sheet now enters a press. Inside, rollers compress the sheet to about a quarter of its original thickness. The next machine layers the thin dough sheet. This flour press and layer process repeats over and over again until the sheet is just 2.5 millimeters thick, yet contains 24 layers. These layers are what will make the pastry exceptionally light and flaky. Trimming wheels on the sides make a neat edge. Diagonally bladed wheels score the dough with small cuts. And cutting wheels divide the sheet into 5 strips, each of which will become a row of turnovers. The next station deposits a line of water droplets along one edge of each strip. This creates a line of sticky dough. The preparations are all done and assembly can begin. First, with precision spacing, nozzles squirt 28 grams of blueberry filling per turnover. Then a device called a folding plow, because it looks like a farm plow, lifts one edge of the dough and gradually folds it over. A smooth wheel then presses that edge down onto the sticky line on the other edge. This seals the open side of the strips. The culinary choreography ends with a bang, or rather a chop, as a guillotine descends, cutting the strips into individual turnovers, and simultaneously sealing the front and back ends of each pastry. The assembled turnovers now go on a 6-minute ride through a nitrogen flash freezing tunnel. Temperature, minus 84 degrees Celsius. Under a shower of sugar crystals, they exit the tunnel, frozen hard as a rock. Packaged 4 to a box, the turnovers remain frozen until you bake them in your oven and serve them up. A car's dashboard is full of dials and gauges that keep the driver up to speed on everything. In the time of the horse and buggy, a dashboard was a wooden panel for shielding the driver from mud and water, hence the word dash, which can mean bespatter or splash. When motorized vehicles came along, instruments were added, making the dashboard an important source of information. Today's dashboards tell the driver a lot at a glance. Ignore the indicator dials, and you could run out of fuel or be slapped with a speeding ticket. A dashboard for a luxury sports car starts with this aluminum skeleton. It's been bonded at the joints with adhesive that's stronger than conventional welds. A technician clips the main electrical harness to the aluminum frame. He fixes the heating and air conditioning unit to the center of the dashboard skeleton and connects it to the wiring. At the next station, the dashboard's composite substructure is coming together. Working from the back, the technician installs a glove box and a network of ducts for the heating and cooling system. The substructure is now ready to join the wired aluminum frame. He rivets the assembly to the metal structure. He slots the driver's information module, which includes the speedometer, into the housing. He equips the dashboard with high-end speakers. The front passenger airbag, encased in aluminum, comes next. The technician inserts it in the molded plastic niche. Using a computerized tool, he installs the airbag with perfect precision. Next up is the steering column, with its magnesium shifting paddles and wiper controls already attached. He slides it into place just under the information module. He then encases the electronics with plastic cowling. This both protects the wiring and tucks it out of sight. He tops off this job with more cowling above. He adds a hand-stitched leather surround to the dashboard's center console. He inserts the center stack, which contains the radio, other audio equipment, and temperature control mechanisms. More leather adds a luxurious look, smell, and feel to the cabin. The next technician assembles push-button controls for shifting gears. He installs them in a veneered fascia through the back to avoid damaging the glossy finish on the front. He inserts vents for air conditioning and heating above the gear shift controls, again sliding them into place through the back of the unit. He secures the vents with screws, then adds the starter assembly. The satellite navigation system gets the top spot, which will put it within easy eyeshot once installed in the dashboard. With this sub-assembly almost complete, he flips it around. It needs one finishing touch: a chrome and glass casing for the starter. He slides it into place, and the unit is now ready for the dashboard. He makes all the right connections and installs the gadget-filled fascia just over the center stack. He now encases the rest of the dashboard in leather paneling. This particular panel has a built-in split, so it will part if the airbag deploys. Next, a technician downloads computer software for all of the equipment in the dashboard. He configures the electronics to the appropriate settings. He then tests each component, confirming that every instrument and control works perfectly. This dashboard now joins all the others, ready to take their place in the front of a luxury sports car. A modern dashboard can define a car's interior space and add serious gadget appeal. For example, this car uses a distinctive steel and crystal key for engine ignition. When the key slot glows red, there's power. It's time to press a few buttons and see what pops up, like this speaker, for example. With a high-tech luxury dashboard, a driver can really travel in style. Pottery is the catch-all term to describe decorative or functional objects formed from clay, then fired in a large oven called a kiln. The pottery is then usually painted. There are several different types of pottery, such as porcelain, stoneware, and earthenware. Earthenware produced on a larger scale is typically cast in molds. This long-time British manufacturer is famous for its bold floral and fruit designs, which feature raised lines. At the factory, the mold maker creates a plaster of Paris model of the piece on a lathe, verifying the shape and dimensions with a profile. He uses the model to cast a two-part production mold, also out of plaster, the model shaping the mold cavity. A caster takes that mold and fills it with liquefied clay, called slip. Once a layer hardens along the cavity wall, he tips the mold and pours out the excess. It takes tremendous skill to know how long to let the clay set before tipping. In about 2 hours, the clay inside the mold hardens sufficiently to be safely extracted. The caster now puts the piece into what they call the damp room. There, overnight, in 100% humidity, the clay fully hardens. It can now be safely worked on a lathe. Using specialized turning tools, a highly skilled craftsman applies just the right degree of light pressure to form the piece to the final shape. In this case, a ginger jar. After applying the manufacturer's stamp, he mounts the jar on a potter's wheel and, pressing with a wet sea sponge, smooths the surface. A designer creates the decoration on paper, then sketches it onto a sample jar. Then she traces her design onto clear cellophane and indicates with red marker lines where the cellophane bends around the jar. An artisan now takes that cellophane and traces the design with a specially designed ink. Using the red contour marks as a guide, another artisan positions and presses the cellophane against the jar to be painted. This transfers the design onto the surface in ink. The ink will disappear once the piece is fired. Next, she creates the design's signature raised lines. The technique is called tube lining. She traces the ink lines while squeezing slip through a tiny nozzle. She uses her artistic judgment to tweak the design if necessary. Not only does this work require a steady hand, she must also squeeze with even pressure to keep the line thickness consistent. The jar goes into a controlled drying room overnight, and from there, into the skilled hands of a painter. With a large artist's brush, she applies just a tiny drop of watery paint. Then, with another touch of the brush, she soaks up the excess paint. She uses her finger to gently blend color transitions. The jar is now ready to be fired in the kiln. The heating phase lasts 8 hours, during which the temperature peaks at 1100 degrees Celsius. This cures the clay and triggers a chemical reaction in the paint, which produces rich, vibrant colors. After a 16-hour cool down, they take the jar out of the kiln and submerge it in glaze, which contains powdered glass. They coat the painted clay surface thoroughly, inside and out. Once the glaze dries, it's back into the kiln for a second firing. This one overnight, at just above 1100 degrees Celsius. The powdered glass in the glaze melts, forming a solid glass layer over the painted clay surface. This seals the earthenware so that it's no longer absorbent and therefore capable of containing liquids. This, of course, is essential for a vase or dinnerware. Glaze also makes the surface shinier, highlighting the beauty of the artwork.